Hello everyone. I just wanted to work through one more of these sets of common ion problems because they can be quite challenging. So let's give this a shot and see how it goes. Alright, so we have magnesium fluoride here. This has a solubility product of 8 times 10 to the negative 8. We want to calculate the solubility in moles per liter of the magnesium fluoride in pure water. So this is going to be the magnesium fluoride, which dissociates into magnesium ions plus the 2 fluorine ions, and that 2 is going to be important. And so then I'm going to think about this as initially I have none of this, right? And then there's going to be a change, and that change has to be stoichiometric. So I have to lose, I'm going to get some dissolved magnesium, and I'm going to get twice that in dissolved fluorine. So this gives me my total equilibrium value of x and 2x and 2x. So then we go over to our equation. 8.0 times 10 to the negative 8 is equal to the concentration of magnesium times the concentration of fluorine raised to the power of 2, because there's a coefficient of 2. Replace that value with the values that we were just given. And then the trickiest part here is to remember to proceed by the appropriate rules. So that means that I need to square that 2 to give myself a 4. And I'm going to put that at the front. And then I'll have an x squared. And then we combine all of those x's, so we get 4x to the power of 3. This is still equal to 8.0 times 10 to the negative 8. So that means that I can divide away the 4 on both sides. And I can also cube root away the 3 to get rid of that. And so that will leave me in a place where x is equal to cube root of 8 to the power of negative 8 divided by 4. And so that gives me a value of 0.0027 is equal to x, and this is going to be in terms of molarity. And that x is 1 to 1 with, that's this x here, right? So that x is here. So that is 1 to 1 with the ratio with the compound. So this is also equal to the total concentration of magnesium fluoride. And that should be the case in all of these questions, that whatever you figure out to be x, it should be equivalent to the compound. I can't quite think of another example where that wouldn't work. Okay, so for the next part, I'm actually just going to copy the setup. I'm going to take a lot of this. All of this top part stays the same. So I'll just bring that down. I might spread it out a little bit because I found myself a little cramped. And but now my ice is a little bit different, right? I'm going to keep that part. Put that right there. And now we are starting with sodium fluoride, which is going to be soluble because it's an alkali metal. So that soluble alkali metal is going to be added in as a starting concentration for fluorine, 0.5 molar. And so this is equal to 0.5 molar fluorine minus. Still not starting with any magnesium. Now, this is the important part. We're dealing with very insoluble compounds. So that means that this value here, relative to compared to the 0.5, this is essentially 0. So we have no effect on the first number, but the magnesium number, it does have a value. And we need that x value because that x value is going to tell us how much magnesium fluoride dissolved. It's equivalent. So now we do the replacement here. We replace the magnesium with x. We replace the fluorine with 0.5. So in fact, these calculations actually get easier as you go. 0.5 squared is 0.25. So I get 0.25x. And so now all I'm going to do is take the 8.0 times 10 to the negative 8. I'm going to divide the 0.25 away on both sides. And I'm going to get like 32, I think. So 8e negative 8 divided by 0.25. 3.2 times 10 to the negative 7. 10 to the negative 7, and that's going to be the molarity of X, which in this case is equal to the molarity of magnesium fluoride. Okay, so now let's try this one. In this example, we have a chlorine. So thinking about that, this is the same as magnesium 2+, and 2 chlorine ions. So if we care about the chlorine ions, then that's going to be important. Otherwise, in this case, we do not care about the chlorine. We care about the fluorine. So, and we care about the, I'm going to steal all of this. Here we go. Okay, copy. We care about the fluorine and we care about the magnesium. So that's the only two that we care about. And so it'll be pretty straightforward here. So now we're going to replace the magnesium value with this starting concentration, 0.50, and the fluorine concentration is starting at 0. Fluorine is increased by 2x, and again, the amount that x is equal to is so much smaller than that 0.5 that we're just going to write that it's pretty much 0.5 molar. Replace your values, 0.5 molar times 2x raised to the power of 2, and that's equals, oops, kind of missed there, okay. And so now we're going to get 0.5 times 4 times x squared, which is going to give us 2 x squared, and so we can bring our number down, 8.0 times 10 to the negative 8, divide the 2 away, and then do your square root here, square root to get rid of that square, and all those go away. And our final value, our final x value is going to be 8, oops, let's set up that square root first, 8e negative 8 divided by 2 to give us a value of 2 times 10 to the negative 4 molar. Okay, and that is equal to x. X in this case is equivalent to the amount of magnesium that's changed. That amount of magnesium that changed is equivalent to the concentration of the magnesium fluoride. The only time this would be difficult, I can see, is if we were dealing with something that had had one of the two ions that was not in a 1-to-1 ratio. So if you had, I don't know, like aluminum oxide, for example. So an aluminum oxide, we would have to worry that there's a 2 and a 3, so x would only be equivalent to one of those. Would have to be multiplied to figure out the concentration. That's not going to happen, so don't worry about it. So that's how we do those questions. I've uploaded the last question as well has been completed, so you can go through that and see if you can follow along, find those answers. And with that, have a great day.